In the previous video, we reviewed polyatomic ions. Please go back to the previous video if you need further assistance with polyatomic ions. We are going to move forward and talk about how to write ionic formulas from their names. We're first going to start with if your name ends in IDE, that means you have two elements. So when you are naming them or writing their formulas, you're going to find the metal on the periodic table and write its symbol and charge. Hopefully at this point in time, you have written the oxidation states at the top of your periodic table so that you know what the metal's charge is. Next, you're going to find the nonmetal on the periodic table. This should say on the periodic table, and you're going to write its symbol and its charge. Remember that the overall goal for an ionic compound is to have a charge of 0, and I'm going to show you how to do that. We are going to do the following items. We're going to start off easy with lithium chloride. Find lithium on the periodic table. Lithium is in group 1, so it has a +1 charge. Find chlorine. Chlorine is in group 17, and it has a -1 charge. So I followed steps 1 and 2. I found the metal, I wrote its symbol and charge. I found the nonmetal, and I wrote its symbol and its charge. Now I'm on step 3. I want the overall charge of this compound to equal 0. Well, if I look here, I have a +1, -1, so our charges equal 0. Therefore, if I want to write the chemical formula, I have 1 atom of lithium, and I have 1 atom of chlorine, so I simply write LiCl, lithium chloride. Next, we have strontium sulfide. I'm going to find strontium on the periodic table. Its symbol is Sr. It is in group 2, so it has a +2 charge. Then I'm going to find sulfide, which is sulfur. It is in group 16, so it has a -2 charge. I've done steps 1 and 2. Now I'm on step 3. I want to make sure the overall charge equals 0. I have +2, -2, which is convenient. They equal 0. So I have 1 atom of each. I have a strontium atom, Sr, and I have a sulfur atom, S. This is the chemical formula. Notice how in both my final answers here, I do not have charges written as superscripts. Okay, I only have it over here to show my work. Next, we're going to look at calcium oxide. I need to look for calcium on the periodic table. It is Ca. It is in group 2, so it has a +2 charge. And I have oxygen. Oxygen's in group 16, so it has a -2 charge. Just like in number 2, our charges balance out to equal 0, so the chemical formula is going to be CaO. I need 1 atom of each. Alright, let's look at potassium nitride. I'm going to find potassium on the periodic table. Potassium's letter is K. It has a +1 charge. And I have nitrogen. Nitrogen is in group 15, so it has a -3 charge. These charges do not equal 0. So I need to make them equal 0. And the only way to do that is to add atoms. So if I look here, the easiest thing for me to do here, so I have 1 -3. Well, if I put a couple more potassiums in here, so I have a potassium with a +1 charge, and I put another potassium in here, and it also has a +1 charge. Now our charges equal 0. 1 + 1 + 1 is 3. -3 equals 0. So when I'm writing my chemical formula, I'm going to look to see how many times I wrote potassium. I wrote the potassium atom 3 times. So I have potassium with a subscript of 3. And I only wrote nitrogen once, so my chemical formula is K3N. Next, we're going to look at calcium fluoride. Calcium symbol is Ca. It is in group 2, so it has a +2 charge. And then I find fluorine. Fluorine is in group 17. It has a -1 charge. Again, my charges here do not equal 0. So what would the easiest thing be? The easiest thing to do would be to continue adding fluorines until we canceled out that +2 charge. So if I add another fluorine, now I have 2 fluorines with a -1 charge, and now they should equal 0. 2 minus 1 minus 1 equals 0. And now I'm ready to write my chemical formula, where I have 1 calcium atom, because that's how many times I wrote it down. I only wrote it down once. And I have 2 fluorines, so I wrote down fluorine twice. And now my charges balance out, and I have 2 fluorine atoms and 1 calcium atom. Next we have magnesium fluoride. Magnesium is Mg. It's in group 2, so it has a +2 charge. And then I have fluorine again in group 17 with a -1 charge. This is exactly like the one we just did. So I'm going to put this up here, follow the arrow. I have 1 magnesium and 2 fluorines. So I write magnesium once and I have fluorine twice. Try to do number 7 and 8. Pause the video so that you can do number 7 and 8. Next, we're going to move on to learning how to write a formula if our names end with 8 or ite. When our names end with 8 or ite, that means we have more than 2 elements, which means polyatomic ion, which you can find on page 7 in your reference table. The one polyatomic ion, there's actually probably a couple, but one that you really need to watch out for is hydroxide. Yes, it ends in IDE. However, it is a polyatomic ion. It's an ion of hydrogen and oxygen together. You're going to follow the same rules. Find the metal on the periodic table, write its symbol and charge, and the only difference now is that you're going to find the polyatomic ion in the reference table, and you're still going to write its formula and its charge. The overall goal is still the same. We want the compounds to equal 0, but this time if you need more than 1 ion, don't forget your parentheses. We're going to do a couple of these. Let's look at calcium phosphate. Here we have calcium, so you find calcium on the periodic table. It is Ca. You write its charge, which is a +2. And then we have phosphate. You're going to look for phosphate in the reference table on page 7. Phosphate is the very last polyatomic ion on your list, and it is PO4. Here, phosphate has a -3 charge. These charges do not equal 0, so we'll have to continue adding atoms to our formula until our overall charge equals 0. So if I add another calcium, now I have a +4 charge. If I add another phosphate, I have a -6 charge. Still not equaling 0. If I put another calcium up here though, however, now our charges do equal 0. 2 plus 2 plus 2 equals 6, so we have a +6 on this side. And 3, -3, -3 is -6, so now our charges equal 0. Now I told you if we need more than 1 ion, we need parentheses. So when you write this formula, you write your calcium. We have calcium. And we wrote it 1, 2, 3 times. So I'm going to put calcium with a 3 down here. Now calcium does not need parentheses because it's not polyatomic. Now we have phosphate. Phosphate is PO4. So I'm going to write PO4 because that's the ion. I cannot forget about this little 4 down here. I'm going to put it in parentheses. And I need 1, 2. I need 2 of them. So I'm going to write a 2 down here. So I have calcium phosphate. Let's look at an easier one. Let's look at number 5 here. Let's look at lithium nitrate. I'm going to find lithium on the periodic table. Lithium is Li with a +1 charge. And nitrate is in your reference table on page 7. It's NO3. And it has a -1 charge. Now these charges do balance out to equal 0, so we only need 1 of each, which means we do not need parentheses in this formula. So we have 1 atom of lithium, and we have 1 ion of nitrate. No parentheses because we only need 1 nitrate. Let's look at potassium carbonate. We have potassium, which is K. It's in group 1, so it has a +1 charge. And we have carbonate, which is listed in your reference table. Carbonate is CO3, and it has a -2 charge. These charges do not equal 0, so I'm going to add another potassium to make them equal 0, because it has a +1 charge. And now I have 1 + 1 - 2. So when I want to write this formula, I have 2 potassium atoms, K2, and 1 carbonate ion, so I have CO3. Again, I do not need to use parentheses because I only need 1 carbonate. Let us do one more. Let's do ammonium chloride. It's a little bit different than the other ones, just because ammonium chloride does not involve a metal. However, we do have ammonium, which is a polyatomic ion. It's the first ion on your list, and its formula is NH4. It has a +1 charge, so we've written that one down. And now we're going to find chlorine, which is in group 17, and it has a -1 charge. Both of these together have an overall charge of 0, so we do not need parentheses because we're only going to have 1 ammonium ion. Remember, ammonium is NH4, so you have to write the 4 down there. And then we have chlorine. I want you to try numbers 2, 3, 4, and 7. You also have a worksheet that includes writing formulas for several names, and I'd like for you to work on those too.